morning, good afternoon, good evening. We are still on a high from the beginnings of our explanations of calculus from yesterday. We are continuing today with a riveting discussion about limits at infinity and beyond. Okay, so we can use limits to discuss behavior of functions for extreme values of x. And all they mean by extreme values of x is as x gets really large or really small. I don't like the wording here. I say this as x goes to positive infinity and as x goes to negative infinity. And they use the word tends to plus infinity. I don't like that wording, so I'm just going to use my own. So there. And a lot of other people use it as well. Here's an important concept. As x goes to infinity, 1 is certainly less than x is certainly less than x squared less than x cubed. And you might be questioning, rightfully so, well, wait a second. If it's infinity, does it matter if it's squared or cubed? Well, we're not talking about infinity. Infinity is not a number. We're talking about as x goes towards infinity. So, like if x is, I don't know, 10,000, 10,000 is certainly less than 10,000 cubed less than 10,000, I'm sorry, 10,000 squared less than 10,000 cubed. So let's think about 1 over x as x gets very large. 1 over x gets very small. What do we mean by that? Well, let's take a quick look here. So let's just do 1 divided by, I don't know, 99. What do we get? 0.011111. So if we do that and then maybe change this to 999, we get another 0 in there. You see how that's happening? But as x gets ridiculous large, let me put in maybe, okay, almost 1,000,000. Well, it's getting closer and closer to 0. Let's push the calculator to the limit. Made a funny there. Limit, get it? All right, so let's put in a bunch of 9s and see what happens. Look at that. Very close to 0. So you can see that as for 1 over x, as x gets ridiculously large, 1 over x goes to 0. So therefore we say that the limit as x goes to infinity of 1 over x is equal to 0. Of course, x can't be equal to 0. Oh, that's up here. 1 over x, limit as x goes to infinity of 1 over x is equal to 0. This holds true for these guys too. The limit as x goes to infinity of x over x squared, well, we can rewrite x over x squared as 1 over x times x over x. And we know that x over x cancels out because x over x is equal to 1. So then that goes to infinity as well. In general, anytime you have a variable with an exponent less than the exponent in the denominator of the same variable, then it's going to go to 0 because of this rule here. This is going to get super huge before this does. So it tends to 0. Okay. So we've studied asymptotes before, but we've really studied vertical asymptotes, a little bit with horizontal. But we can talk about the horizontal asymptotes and the vertical ones really in terms of infinity. So if I look at this function right here, here's the graph of it, the graph of the function, the black lines, and we have a vertical asymptote at x equals 4, which I hope is obvious because if x were equal to 4, then the function would be undefined because 4 minus 4 is 0. Okay. And we can see just from the graph we have a horizontal asymptote at y equals 2. Okay. So let's think about this in terms of using infinity to discuss it. Okay. As both of these asymptotes can be described in terms of limits. As x approaches 4, now that doesn't mean negative. If x approaches 4, then with this minus sign, that means from the left, from the negative side. Okay, so as x approaches 4 from the left, let's think about that. So x approaches 4, it's going this way. This is my x value, remember. As it's getting closer and closer and closer to 4, what's happening to f of x, right? Well, the corresponding value is here. And if I go even further, the corresponding value is down here. And as I get closer and closer, this arrow indicates that it's going down, 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 down to negative infinity. And we know it's not going to cross this because it's a vertical asymptote. By the same reasoning, as x approaches 4 from the right with the positive, so coming in this way, what's happening to the function f of x? Well, okay, let's think about this point. Well, the corresponding point on the function is right there. Here, it's maybe at the tip of this arrowhead. As we get closer and closer to 4 from the right, it's going further and further up. It is going to positive infinity. Okay. Now, what happens as x goes to negative infinity? Well, x going to negative infinity means x is going this way. Way, 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 way over here. Well, what's happening to the function? Well, the function is getting closer and closer and closer to the line y equals 2. Closer and closer and closer. And this means that, and this is true when we're talking about the function is approaching 2 from below because it's below this asymptote. So here, when we're talking about the function, the negative indicates from below. And of course, the positive indicates from above. And that's what happens as x goes to positive infinity. Wow, that was awkward, that positive, I'm sorry. As x goes to positive infinity, then this function gets closer and closer and closer and closer to the line y equals 2. We can say it converges, but we don't use that all that much in this particular study of calculus. Okay, so what does all that tell us? Well, let's discuss the behavior of f of x equals 2 minus x over 1 plus x near its asymptotes, and hence deduce their equations. Now, you are allowed to graph this to take a look at it. Okay, so this right here is the graph of 2 minus x over 1 plus x. We know for sure that there is indeed a vertical asymptote right here at -1. So I'm going to draw that in there. Oops, I'm not going to draw it in here. But it would be right here at x equals -1 because it would be 0. And it looks to me like we have a horizontal asymptote at y equals -1. What might help us see it is if we go ahead and graph -1, if we suspect that's it. And then you can drag the graph further and further and further and further and further and further. In fact, if you really want, you can make that like, I don't know, 1,000. And it appears to be one line. So x is equal to 1,000 here. And you're like, wait a second, it looks like it might be intersecting it. Well, we can do a little zoom box here and see if it really is. So I'm just going to take a look here, my zoom box, and you can see it's below it. I'm going to zoom again, and you can see that they don't intersect. Okay. So let's look again. Let me get back to the original graph. The same is true as I approach negative infinity, as x approaches negative infinity. Okay. And what about when, let's see, let's do this here so we can talk about it on our graph. Okay, oops. Let me move this out of the way. Oops, I'm having troubles. Houston, we have a problem. Okay, so we talked about that vertical asymptote right at -1. Right here. Sorry, that's not very accurate. So we need to discuss the behavior of the graph near all of its asymptotes. So we have an asymptote at x equals -1 and also at y equals -1. Okay? So we're going to say as x approaches -1 from the left, f of x approaches. So as, think about it, x is approaching -1 from the left. What's happening to the function? It is going to -infinity. And as x approaches -1 from the right, f of x, let's see, -1 from the right. So coming here from the right, what's happening to the function? It's going up, 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 up. It's going to positive infinity. Okay? And then, so you have to find that vertical asymptote and discuss it. And then as, let's see, as x approaches -infinity, what's happening to f of x? Well, it's approaching -1. The function is approaching -1 as it gets closer and closer. And as we're going to -infinity, it's approaching from below. So I'm going to put a negative there. And as x approaches positive infinity, f of x is approaching -1. Here we go. X goes to positive infinity right here. My function is getting closer and closer to -1 from above. So we can say from this observation that the limit as x approaches -infinity is equal to -1. And I should say the limit of f of x there. And the limit as x approaches positive infinity from f of x is also equal to -1. Okay, hang in there. One more example. Almost done. Find, if possible, the limit as x approaches -infinity of 3 minus e to the negative x, and also as it approaches infinity, the same function here. So let's think about this. I'm going to call this one A real quick. A. So let's think about 3 minus e to the negative. Now as x goes to -infinity, let's think of something small. Let's let x be -100. So this negative comes from here, and if I replace x with a -100, what do I get? Well, that equals 3 minus e. A negative times a negative is a positive, e to the 100th power. Well, e to the 100th power, remember e is approximately equal to 2.71. Well, that's 2.71 times 2.71 times 2.71. That's a huge number. So the limit, that means it's going to be 3 minus a huge number. And the bigger we let x be, like if we did -10 quadrillion, it's going to get even larger negative. So we can say that the limit as x approaches -infinity does not, we'll call this f of x, does not exist. Okay? If it goes to positive infinity or -infinity, we say it does not exist because infinity is not a number. Okay? And what about here? Let's think about 3 minus e to the negative x. So this is going to positive infinity, so let's let x equal positive 100. So this becomes 3 minus e to the -100. And what can we do with negative exponents? Well, that becomes 3 minus 1 over e to the positive 100. Right? So 1 over something huge, this guy, if we throw in a couple more zeros, it becomes e to the 10,000 or even 100,000. This part of the expression is going to go to 0, and we're going to be left simply with 3. So that's looking at it, just sort of thinking it through and trying out some numbers. You could also take a quick peek at the graph, and you can clearly, well, I don't know if you can clearly see, oh yeah, you can clearly see it, that as x goes to infinity, it gets bigger and bigger and bigger and bigger. It's certainly approaching something. It looks like 3. And if you're not sure, just graph the line f of x is equal to 3. And you can get a pretty good picture of it. And if you're still not convinced, you can do the zoom box trick. Okay? And what's happening as x is going towards the negative is the function is going down, 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 down JSON. Are you down? Going down to negative infinity. Okay, hope you enjoyed it. I am out!